Okay, this is worth repeating because we're going to see it again. So if you get something in the second quadrant, how do you find the reference angle? You subtract it from 180. Okay? In the third quadrant, you add it to 180. Okay? In the fourth quadrant, well, what's the shortest distance here? Subtract it from 360. You get the reference angle. You guys have done this already. You know that. But like I say, in a minute, you'll know why I'm emphasizing that. And how do we remember what the sign is of all these three ratios? Cast is what I like. You like to make your own. Be my guest. Okay? Remember to start in the fourth quadrant, though, and go counterclockwise. C-A-S-T. Okay? And if you do that, you don't need to memorize, Tyrannosaurus Rex and 7 yellow rabbits and God knows what else. Okay, you can just quickly do a picture and figure it out. Okay, there's some point. How do I get there? There's X, there's Y. Okay, if this is on some circle, I can call that a radius, call it R. R is always positive. I don't care where. Okay, that would be negative X, that would be negative Y. There's R. Okay. Theta is always from the origin. So if I want to know all of my ratios, just figure it out. Okay? Sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. And tan of theta is opposite over adjacent. Okay? Takes 10 seconds to draw that little picture. Okay. So exact values of trig ratios given a point on a terminal arm. You did a couple of these already. We're just going to expand it. Apparently you only did it in quadrant 1. That's what this says. Okay. Well, let's do it in a couple of different quadrants. Point, -3, 2. Stop right there. If you don't have one of these, you draw it. Where is that? -3, I go from here to here. 2, I go up 2. There's my point. There's the coordinates of the point. Okay, it's important to do that in the picture. Picture's worth 1,000 words. Because some of you guys, what's the distance of OP from the origin to this point? There it is. That's what you want to see. Some of you guys are doing all sorts of strange stuff. Okay, you don't have that. You have like, oh, there it is. I'm like, what is that? Okay, or you go like y, yeah, there's y, okay, y was, 2, and yeah, -3. Sure, you got to the same point, but that's not as helpful. Okay, just like you plot the coordinates, you want to go -3, 2, because then that triangle tells you where theta is. If you don't draw the right theta, if it's over here, you're not going to get the right ratio. Okay? That's theta. Okay? Complete this. Determine the values of the primary trig ratios. Sketch the rotation angle on the grid. Mark the point on the terminal arm. So that's my terminal arm. Let's call it R. Pretend this is like a circle and that's the radius. Okay? Calculate the exact length of R. Okay, well, this is Pythagoras, right? C squared is A squared plus B squared, all right? C, of course, is the hypotenuse. It's always the longest side. It's always the side opposite the right angle. So C is R. R squared is, doesn't matter which one's A and B, but when you substitute in for A, use brackets. When you substitute in for B, use brackets. It's not going to matter if it's positive, but if you get in the habit of doing it, you're not going to forget this. And you're not going to have like -9. You'll get the correct thing, which is +9. Okay? So that's 4 and 9. That's R squared. What's R? Take the square root of that. That's root 13 exactly. Don't make it a decimal. Okay? So, use x is minus 3. Yep, I already knew that. Y is 2. Yeah, I already knew that. And r, now I know r is root 13 to write the three trig ratios and simplify it. It doesn't say it there, but you should. Okay? So sine of theta is opposite over hypotenuse. Okay? But is that how we want it? Or can I simplify that? Because if you look at the answer, it won't say 2 over root 13. This is going back, 5-6 weeks ago. Radicals. We're going to tell you that's not simplified. It's not simplified because I can rationalize this denominator by multiplying top and the bottom by root 13. Okay? Don't ask me why it's more simplified when you do this. Just go with it. Okay, what's root 13 times root 13? Root 13 squared, or root 169, which is 13. Now the denominator is rational. It's rationalized. That's a rational number. Root 13 isn't. It's irrational. Okay? Now, don't believe me? Put it on your calculator. Square root of 13, that keeps going on forever and ever and ever and ever. It's an irrational number. And on the top we have, 2 times root 13. This is simplified. Okay? That's how we want it. Cosine is cap, adjacent over hypotenuse. This is the adjacent. Hypotenuse is still root 13. Okay? I want to rationalize the denominator, multiply it by the same thing, and the root goes away. And now I have minus 3 root 13. Okay? Tan. What's the ratio for tan? TOA, O over A. Opposite over adjacent. 2 over negative 3. Okay, that's the same thing as minus 2/3. You'll know why in a sec why I'm writing this out 3 different ways too. That's the same thing as minus 2 over 3, right? These are all the same. Doesn't matter where you put the minus, right, Lewis? Yeah, that's right. Okay? All right. The point 4, negative 4 minus 2. What's the first thing we should do, Carmen? That's right. Draw a picture. Minus 4. Let's do this in a different color. There it is. Minus 2. From this point, you go minus 2. There's r. This is theta. If you do that every time, you probably won't make a mistake. Okay? Try to do it in your head. You probably will. Okay? I don't want all 3 ratios. I just want to know what sine theta is exactly. Okay? Well, what do I need for sine theta? You can think of that as y over r, or you got a picture here now. You don't really need to know this. This is opposite. Carmen, come and sit up here, please. Okay, r. I don't know what r is. Need to know it. Okay, r squared, that's the hypotenuse, is minus 4 squared plus negative 2 squared. So r is the square root of 16 and 4. Okay, which is root 20. Can I simplify that? What's the perfect square in 20? 4. So root 20 is root 4 times root 5. And why did I do that? Because I know what the square root of 4 is. It's 2. Okay? So that's what r is. Let's throw them up here. So the sine of theta is opposite over hypotenuse, or y over r. Don't have to write it in your picture, but might as well. Okay, can I simplify this? Yes, well I need to rationalize the denominator, but before you multiply the top and the bottom by root 5, can I simplify it? Is there a 2 on the top? Yeah. Is there a 2 on the bottom? What's 2 divided by 2? 1. Okay, let's make it nicer. Now I'm going to multiply top and the bottom by root 5. So that's minus 1 times root 5, or just minus root 5. Root 5 times root 5 is 5. Okay? Exactly, simplified, that's what sine theta is. Okay? All right, now, given a different trig ratio, what's the value of a trig ratio? What did I tell you in grade 10? If you don't know the angle, what button are you pushing on your calculator? Inverse or second function. I don't know this angle. Okay? We're going to have to do that. Okay, let's determine what cos A is and tan A. This, we're kind of leading us through it. Picture's worth 1,000 words. Since the sine of A is negative 4/5, okay, and it's telling us this is in the third quadrant. Okay? So I don't know what my angle is, but I know it's there somewhere. I know to get there, I have to go some value x and some value of y. Okay? Okay, since sine of A is negative 4/5, or negative 4/5, or 4 over negative 5, that's y over r. Let's put r in there. We know that this point must be, okay, x negative 4. Okay? R, is that positive or negative? R is always positive. I don't care what quadrant it is. Okay? To get to this point, I know x is negative and I know y is negative. So when you're looking at this minus 4/5, you know r is positive. So if you like, you could write that as, okay, y, I has to be negative. So that probably makes more sense, doesn't it? Okay? Y here is negative, so let's put the negative where the 4 is. R is positive, so let's put the 5 there. Okay? That's what this is saying. Y is negative 4, R is 5. Put it on your reference triangle. Okay? So that's negative 4. R has to be positive. It's 5. Okay? Should I say that again? We don't have a choice of where this negative goes. It can't go with the 5, because r is always positive. And you know, getting to this point in quadrant 3, y has to be negative. Okay? So that's why we're saying y is negative 4. That's where the negative is. Okay? It's not on the 5. R is always positive. Okay? So sketch a diagram. There it is. Let's determine what x is. Okay? Knowing that, well, you know x is negative here. Let's see what we get. Okay? So I know c squared is a squared plus b squared. The light's inside it.
Okay.
It's going to go into the display case. It'll be fine. Yeah. Okay. C is R. So I don't know, again, from grade 10, do you guys put the numbers in, then solve this? Or do you just solve that thing right away for x squared? Either way, we should get the same answer, right? Okay? To solve a leg here, right, if I want to solve that for a squared, I minus b squared to both sides. And a squared is the hypotenuse squared minus the other leg squared, okay? So one of the legs squared is the hypotenuse squared minus the other leg squared. Okay? I don't know. Do you put the numbers in first or do you do this? Okay, this is kind of my thinking, but if you want to put the numbers in, then solve it, that's fine. So, what's R? 5. Minus, what's y? Negative 4 squared. See how the brackets are important here? Actually, I should heed my own advice and do that. Okay? So that's 25 minus 16, which is 9. That's x squared. Take the square root. Is x 3? So remember, when you take a square root, like 3 times 3 is 9, but what's negative 3 times negative 3? It's also 9. So technically you need to go plus or minus. Remember, x has to be negative here, right? You can't use the positive value. That doesn't make any sense. If you drew a picture, it should be pretty self-explanatory. That's why you want to do that. Okay? And this is your 3, 4, 5 Carpenter's triangle, isn't it? I've said that before, right? Okay? Okay, what is cosine of A? Do you know how I got 3? Okay, let me. Okay, cosine of A. What's the ratio for cosine? If you got a picture, it's A over H, or if you memorize that little thing, X over R, either will work. What's X? I now know that's negative 3. R is 5, so that's the cosine ratio, okay? Minus 3/5. Okay, tan is O over A. Negative 4 over negative 3, which is 4/3. Okay? All right. Now we've got to think of it like we weren't already, right? Tan of theta is negative 2/3 and cosine is positive. Find the exact value of sine theta. What quadrant is this in? First, look here. Where is tangent negative? Here it's positive. They're all positive. Here it's positive. So where it's negative is quadrant 2 or quadrant 4. Okay? But which quadrant is cosine positive? So this guy's in quadrant 4. That's your only choice. Okay? Here it is. So what do you know? Well, I know to get to this point, I'm going to go sum x. I'm going to go sum y. I know x is positive. I know y is negative. I know for theta, the tangent ratio is opposite over adjacent, or y over x. Okay, so that has to be 2. X has to be 3. Where does the negative go? Okay, because it's minus 2/3, not positive 2/3, right? It's got to go here, doesn't it? Because y is negative here. X is positive. Okay, that's your only choice. That's the only thing that works. If you're not drawing a picture, well, good luck. All right. What do I need to find before I get sine? Got to have a hypotenuse. Okay. What's r? R squared is a squared plus b squared. 9 and 4 is 13. So r, can I skip a couple steps? Root 13. So once I know the opposite and I know the hypotenuse, it's just SOHCAHTOA. Actually, sine theta to be accurate. Okay, and then the radical part, well, the answer is not going to look like that. That's not simplified. Let's times top and bottom by root 13. So sine theta is minus 2 root 13 over square root of 169, or root 13 squared, whatever way you want to think about it, that's 13. Okay, so 2 pieces of information. We got to figure out what quadrant this is in. Let's cut it off right there, okay? Is that good? That's enough to absorb? Now I got to figure out what questions you can do and what you can't. 1 I know you can do. 3. No. We got E blocks, so I just want to not kill you guys, okay? 5. 8. And 9. Okay? So that's like part 1. Part 2 we'll do tomorrow.